Good morning, everybody, for being here today for this CISTER internal seminar. It's really my pleasure to welcome here Anis Koubaa, who is a senior PhD member of the group since 2005, so long time now. AI and IoT-based techniques have popped up in recent years, and at some point we need to stop and look back and check and do a kind of overview. So he will have around 45 minutes to entertain us on an overview of AI-powered IoT smart systems. Just to mention that Anis is also the head of the robotics and IoT research group in Prince Sultan University in Saudi Arabia. And maybe Ricardo would like to add a few words.
Yes, thank you. Okay, so this is usually the kind of introduction we always give to every distinguished seminar that we host at CISTER, but I believe that Anis deserves some extra words. I had the pleasure and the privilege to work with him while Anis was still a young postdoc. Since between 2006 and 2008, more or less. Yes. And it was definitely inspiring for me and quite helpful for as a junior researcher at the time to have this privilege to work with him and to witness the dedication and the excellence that Anis always gave to his work, and it was definitely also inspiring throughout my PhD. So I think this this is something that I would definitely would like to state here. And this is also, remember at the time I was a young licentiate and master student, and I was also working in robotics, so similar to what other master students that are working with me are doing right now. So this is kind of, this brings some memories from that time. I would like you to, I hope that you like and enjoy this seminar as much as I will definitely enjoy. So thank you very much and welcome back.
Thank you very much, Ricardo. Bismillah ar-Rahman ar-Rahim. Wassalatu wassalamu ala nabiyyina Muhammad wa ala alihi wa sahbihi ajma'in. Thanks a lot for the introduction. Actually, it's a great honor and a pleasure for me to be here. Let's say it's my house, CISTER, and I'm really glad to provide you today an overview about current research activities. And the objective of this talk is to give you some introduction about AI-powered Internet of Things system, but also to give you an overview about what I'm doing, and probably the most important thing is try to establish close collaboration with some people here in CISTER working around these areas. Okay, so my talk will be an overview about AI-powered IoT smart systems. And thanks Josh for the introduction. So I'm Anis Koubaa. I'm currently Elected Director of Research Governance at Prince Sultan University. So I'm taking care about responsibility about the governance of research and setting up rules in order to promote research at the university. I'm also a full professor in computer science. I've been integrated research in CISTER since 2005. I'll give you some history just in a moment. And I'm leading the robotics and Internet of Things research lab. I also give some consultation services to Gatech Robotics in what concerns development of robots and drones as well. And we are responsible for developing the software and APIs for the robots of Gatech Robotics. So my research interests are a little bit broad, but basically they fall inside three main areas: IoT, cloud robotics, and deep learning. So the history started 14 years ago. I think, Eduardo, you remember these emails. These are the first emails that we exchanged with Eduardo. It was in January 2005. Yes. Oh, yeah. This is 14 years ago. And I remember I submitted my application on 31 of December 2014. It was, I think, the last time for the submission. And I was fortunate to be selected as a postdoc. And later on, I came here for an interview, I think around February, and then I joined CISTER during the month of May to work for 1 month, and then I started my postdoc in August 2005. So this is actually, and I'm really owe too much to CISTER because I consider that my real start of research, it started from here. I learned in 1 year, also, although I spent only 1 year in CISTER, but I really learned a lot of best practices in research, and also I was deeply involved in the scientific community of real-time systems, wireless sensor networks, so I knew a lot of people, and our first papers were actually had a good impact on the community. Okay, so, and then in 2006, I moved to Saudi Arabia, but still I kept all along the time until now my relation with CISTER, and I worked for Imam University until 2011, and then I moved to Prince Sultan University. So this gives me like a broad experience about teaching and research in different teaching and research environments. So, and my research started with wireless sensor network initially, and we worked a lot on the 15.4. We have a lot of pioneer papers on 15.4 in different areas. So we worked on link quality estimation, we worked on the link layer, on real-time aspects. We also worked on security, and later on localization of wireless sensor networks. So in 2012, I started to look a little bit on robotics, and the idea is because in Saudi Arabia, they don't really care about the theoretical research and about this. So I try to have something that actually we can demonstrate, we can show off. So try to look, the first thing I try to do is to integrate robots and wireless sensor network together, just using my background and trying to move smoothly to the robotics area. And then until I, let's say, fall in love with ROS, and I invested more deeply into the robotics area because I consider ROS like is a revolutionary platform and framework to work with robots. Because for me as a computer scientist, I don't want to care about low-level aspects about programming robots at the low-level drivers and low-level stacks. So ROS gives you a very good abstraction to focus more on your applications. So everything related to navigation, drivers, hardware, and everything is taken into consideration by ROS. So here I start to move more deeply into the robotics area. I proposed 3 projects, and then gradually we moved to the unmanned aerial systems. The first project was to actually propose a system that controlled the drones over the internet. I will tell you why I want to do that. And now more recently, I try to work a little bit also on deep learning and artificial intelligence. So this is kind of history about the research evolution over the last 14 years. So I'm proud to say that I'm the first one to establish a research lab at Prince Sultan University. I would say that maybe 3 or 4 years ago, the university established itself as a teaching university. They don't care about research. Alhamdulillah, after some time, they got confidence, and they are more aware about the importance of research because of ranking aspects, because of the reputation of the university. And I'm the first one to establish this research lab, and now it opens up the doors for other labs as well. Now we have 4 research labs at the university. One on cybersecurity, one on blockchain and data science, another one on data engineering, and my research lab on robotics and Internet of Things. So these are the facilities that we do have here. This is the space. And this is the kind of activity that we organize. So also we organize some trainings for students, to attract students to our lab. This is a training that we did in last May on how to build a drone from scratch. So because we have prior expertise on building drones over the project that we have conducted in the previous years. And this actually helps to attract students and get them more involved into research. Even undergraduate students, actually, they can help a lot. Because for the moment, we don't have a PhD program, but we have some other alternatives. Like, for example, we can invite PhD students from anywhere, and also master students as well. Okay. So currently, we have a very small team. It includes myself, my colleague, Dr. Bassett, Bilal Bijdira, a research assistant, and 2 research engineers, Ahmed and Maram Ajlan. And just to give you an overview about the KPIs in 2018, we were able to publish 12 journal papers. So most of them are in high quality journals, Q1 and Q2. We were able to also generate some fund from training and from the industry. So we generate funds from local industry and also from outside, from basic robotics. We published 6 conferences, 3 books, 8 book chapters, and we conducted 3 training programs. And I have 2 PhD students who completed their PhD. So for 2019, you can see there is much more improvement. So we were able to generate a little bit less than 50,000 euros fund. And so far we have 9 publications. Most of them are Q1 papers. We have 7 conferences. And we invited 2 big names in networking in Valence. Muhammad Yunus from University of Maryland, Baltimore County from the US, and Professor Azadin Mukash from University of Ottawa. Professor Azadin is likely to join us also in the lab. He's going to have sabbatical and join us for the next year. And we are recruiting 1 postdoc and 1 researcher as well. And we have 1 invited PhD student for China. And the door, of course, is very open for any students to come and visit us. So we have opportunities from 1 month to 6 months, also funded in some of the ways by the university as well. Okay, these are the openings that we have now. So we are recruiting research professors, and we have postdocs and also PhD internships on the different areas like UAS, IoT systems, deep learning, self-driving cars, and cyber-physical systems. These are some selected projects that I'm working on currently. So I have a PhD students working on safety and security of the Internet of Drones, because we have established the functional properties of IOD, the Internet of Drones, and now we are looking more about the security aspects and safety aspects. And we work also on analysis of aerial images using deep learning and semantic segmentation. I'm going to provide an overview of all these different things. We have a collaboration with one company. This is the biggest IT company. It's responsible for the IT project of the government. So we're working on a small project about smart palm, monitoring palms and detecting the weevil insect using IoT. We have also collaboration with Machine Store Company, another big company in IoT. And they sponsor us by providing us IoT equipment. So we are trying now to make our campus smart. We have already installed a smart parking application. So they provided us the sensor, and our students, they developed the application. And of course, everybody knows that we work with Harrison on 15.4e, and we have good results so far, and also with Ricardo on vehicular plateaus. So I'm going to talk about the integration of robots and drones over the IoT, and this is how I started my research in the area. So back in 2014, I remember at that time I attended the conference in Germany, ARCS, or?
In
2014.
ARCS,
yes. So I attended I think I made also a first talk here in CISTER, in which I present our first work about the teleoperation of robots through web interfaces. It was very basic work at that time. And later on, I developed like a service robot. So we use mobile app in order to send commands to the robot and navigate, and this is using ROS as well. And that started to face some difficulty because I was able to operate the robot only in the Wi-Fi range in local area network. And this is quite limited. So at that time I was asking myself, how can I actually control this robot remotely? I want to be at the house and actually send the robot anywhere, and they can monitor in real time video stream so I can make surveillance online. So I was thinking about how to overcome this problem, especially to overcome this limitation range of the Wi-Fi. And if you look at the first floor of the CCIS of our department, it's very large, and we can only operate the robot in this very small size. So I started to look at some works related to cloud robotics. Okay, and cloud robotics, it's an emerging area. It started since 2010, and basically it consists in providing two services. First of all, it allows you to access the robots remotely, or seamless access the robot through service interfaces. This is what we call virtualization. Now, with the emergence of cloud, everything is virtualized. Okay, you can, for example, you store your file in Dropbox. You don't know where they are stored. You don't know in which physical location, but you know that they are stored somewhere. Anything now becomes virtualized through service interface. So the idea is actually to make robots or any or sensors also like virtualized, so anyone can access them through software interfaces. This is what we call virtualization. And the second thing is computation offloading, because usually robots, sensors, or drones, they are energy limited and they don't have sufficient computation capacities. So what we want to offload the computation from these devices to the cloud, so the cloud can perform extensive computation and then sends back the result or sends back the command. These are the two main lines of cloud robotics, and if you want, I have a paper that is going to appear soon in the Encyclopedia of Robotics. It provides a brief summary about these different categories. So some of the inspiring works was the European project Robot Earth, who developed a complete system that supports the collaboration of robots. So you can see robots, they can communicate with each other through the cloud engine, and they have database that stores all the different missions and tasks, and it represents a shared knowledge among all the robots. And also, another work which is also inspiring, this is the ROS Bridge. Okay, and ROS Bridge allows to access the robots through web interfaces. But the problem of ROS Bridge here, so if we consider the robot, they install the server in the robot itself. So what does it mean? So if you want to access this server, it means that you need to have, the robot needs to have public IP address. If you are in a local network, it's easy. But if you want to access the robot from outside, anywhere in the world, you don't have access to the IP address in the local network. Maybe you can use NAT, okay, translations or something like this, but it's not something like straightforward. So I didn't want to go for this direction. I want something that allows me to access the robot without any needed configuration on the network side. Okay? So I started looking, and recently there are several surveys and papers, and they can categorize the robotic system into, for example, here 3 categories: robots that are standalone, robots that are networked, like ad hoc communication between robots, and cloud robotic system, which are connected to the cloud. So I was more looking into the cloud robotic system concept. This is also a recent paper that tried to use edge computing for the coordination of swarm of UAVs. So it's really the trend nowadays. If you look at papers in 2018, 2019, a huge amount of people are now trying to find out a way to integrate robots and drones over the internet using edge computing or cloud computing approaches. Okay, so at that time, until maybe 2014, 2015, I still didn't find the best way how to implement my idea for teleoperating robots over the internet. And then I worked on another project that is related to drones. And drones also have the same problem. So now if you buy a DJI drone or any drone from the market, you need to have line of sight communication with the drone, right? Okay, so you are going to connect it through Wi-Fi or through telemetry. And the best that you can have, maybe you can reach 7 kilometers of range. But beyond some range, you are not able to access the drone. So still we have range limitations. So, and the classical way is that the drone is going to communicate with the ground station through a certain protocol. So in our case, we use the Mapping protocol for Arduino pilot systems. And we wanted also to overcome the communication range. Okay. So then we got the idea to use a cloud-based system. Okay, so the cloud is going to be a big server located into the internet. So we solve the problem of public access because the cloud usually has a public IP address that you can access, of course, if you are authorized. And we will use the cloud for two things. First of all, for allowing the access, so it's going to act like a proxy. If I have something to send to the drone or to the robot, I send it to the cloud, and the cloud is going to forward to the robot or to the drone. Another advantage of the cloud, because it has huge computation resources, okay, so we can offload computation from the drone or the robot into the cloud. So the first step were how to close this loop, okay, ensuring the command between web interface or mobile interface to the robot or the drone. Okay, so for the robots, we did the same thing. So the robots actually, they are using ROS, okay, and ROS, what we did here, we developed a ROS-link bridge, and in the cloud we have implemented a ROS-link proxy. So what happens? ROS-link bridge is responsible for taking any information from ROS and send it using software APIs like WebSockets or UDP to the ROS-link bridge, the proxy. And the proxy is going also to forward these states to the client, and we take the command from the client, send them to the ROS-link bridge, and the ROS-link bridge is going to transform this into ROS commands. So we can make the robot move, we can make the robot navigate, we can do anything. So we have developed a complete protocol that we call the ROS-link that is inspired from the Marlin, and that allows to make all this working. And now, with ROS-link, it's possible, if you have any ROS robot, it's possible to just build its ROS-link bridge and plug it into the system so you can have full control of it. So this is the first problem of ROS. So people who work with ROS, they know that for any ROS robot, you need to have a proper ROS master, okay? And the ROS masters are completely independent from themselves. So now if you want this robot to communicate with this one or this one, there is no means, so maybe you need to make something artificial or manual for ensuring the communication. One possible solution is to make one ROS master for all, maybe put it in somewhere, big machine, but it's not scalable. Problem of naming, problem of scalability, okay, it's too much headache. So this also is not very suitable. So this is why we make a complete decoupling. Everyone has its own ROS master, but is going to have to develop its ROS-link bridge, which is just a Python node, okay? It's a ROS node, but we subscribe to the topics of interest and publish to the topic of interest, and we interact with the cloud proxy. Cloud proxy is going also to communicate with the different users. So the ROS-link cloud proxy is going to manage users, going to manage robots, and do all the different things. Of course, real-time aspects are important, so we have evaluated this into an open-loop control. Of course, you can see that depending on the network quality, this is, for example, if you run on local machine, you don't have any jitter, you don't have delays. But of course, if you run on different networks, so the delay and jitter can be more significant. And you can see, for example, here can be a difference between this is ROS and ROS-link. So you can see with the delay, we can have a little bit bigger circuits because of the delay would have an impact. But of course, it's probably not very appropriate for hard real-time applications. For soft real-time, it may still work appropriately. So in terms of application and implementations, we have implemented the full system. So this is the interface. It's a web interface, okay, where we can have the list of all drones or robots connected. Okay, so everything runs through the cloud. And now you can see a demonstration. And by the way, this is the football field close CISTER here. Okay, so this is CISTER, by the way, here. And let's assume that you have a drone. Okay, not very far. Okay, so through the web interface, you are able to plan your mission. Put waypoints anywhere you want, and then you can send the waypoints to the drone. Okay, and then you can send the command to the drone. You can arm. So guided mode, it means that it's going to follow the different points. And here we will take off. Okay, so take off. You will see now the attitude is changing. Okay, and now going to the autonomous mode. Autonomous mode, it means this drone is going to follow all the points in order. Okay, so the objective of this work, you can see now the drone is moving. The objective of this work is to demonstrate that this is feasible. Okay, so we implemented the system, we tested on simulated drones, and we tested also on real drones. So it was proven to be working. It's not as easy as it might seem. It took a lot of time. I crashed a lot of drones, okay, until I made it work. Okay. Okay, so the good thing, this application is generic. It can be used in different contexts. I'm going to show you some of the things that we thought about where we can use this kind of application. So for example, it can be used for accident resolution. In Riyadh, for example, you have a lot of traffic jam. One accident, it may make the life of drivers a nightmare. Sometimes they will waste maybe 1 hour or 2 hours just to solve the accident because they have to wait for someone to come and take notes and so on. So we can use drones. We developed a small prototype. It was in simulation. So in case of there is an accident, for example, someone can use a mobile application and can load the image of the accident, as you can see, and send it to a control center. So the control center will use a dashboard. Okay, it will receive the accident request, and it will locate the accident location. It will assign the closest drone. Okay, and then the idea is that the drone goes to the location of the accident, takes pictures, and make a report. And by the way, we just after we finished this in 2017, in 2018 we have saw an advertisement from the government that they are planning to do the same application. They are planning to do the same application for but so far it was not really implemented. I even talked with the authorities there about the possibility to implement this with real drones. Also, we were concerned about the quality of service and real-time aspects. So we have developed a drone tracking application using GPS location. What's the idea? Is someone will have a mobile phone, and this mobile phone will get the GPS location and send the GPS location to the cloud, and then from the cloud it will send to the drone, and the drone is going to follow the person. So we implemented this with a real drone. You can see, okay, this is me with the football, and I have a mobile application like this one. So I can send a follow me request to the drone. Okay, and you can see now the drone is almost 20 meters in the beginning until it comes at the same location of me. Okay, I will be waiting for the drone to come. You will see it in a moment. Okay, so you can see now the drone is moving. You see it? Okay. So by this work, we wanted to evaluate what will be the impact of the communication quality on the tracking error. Of course, the best tracking will be when it's the same as the position, as the moving person. So you can see that the drone is actually following with some gap. Okay, it depends on, for example, maybe around 5 meters. If you run, it can be up to 11 meters. Okay, at this time it lost communication, so the drone didn't actually follow. So, and here we have tried different configurations, like for example, changing the communication quality, changing the speed of the object, the acceleration of the object, and we have a paper last year in IEEE Access where we analyzed the different scenarios. Okay, so you can see the impact of the acceleration tracking distance according to the vehicle speed. We tried it also on a vehicle, so I was driving on my car and having a mobile app, and I have a simulated drone, okay, trying to follow, and then we computed the gap between the for the tracking distance. Also, another advantage of this application is that it allows you to program the drone with an abstract manner. You can use web services. Okay, look now, for example, we have a web service interface. For example, if I want to take off the drone, I don't care to know about which drone I have. It can be DJI, it can be anything else. Don't care, custom drone, anything. For me, I care that the cloud service provide me a software interface that allows me to send a command, take off, and I specify the drone ID and the altitude. And it's up because you know that web services, they make an abstraction on the systems. And we have SOAP web services and REST web services. Okay, so here we have implemented SOAP web services. Okay, and in this case, you can develop programs. So this is a client API that we have developed. It's my own language. I developed a client API. For example, when I can do drone.connect, if it is yes, in this case, I can, for example, get the host ID, the remaining battery level. I can send an ARM command. I can send takeoff command. It can be for any drone this code. Okay, because we will interact with web service interface, and this is web service client that allows to put in Java. It can be done in Python or in any other language. So it gives you flexibility on how you can define mission using programming languages with drones. Another work also that we considered is using drones for disaster management. This is a little bit more theoretical, but here we have investigated coordination strategies between drones in order to rescue people during disaster. And my students developed an algorithm that was proven to outperform some benchmarking algorithms in the literature. Also, this is an IEEE Access paper recently published in 2019. Okay, now at this stage, we have made all the functional properties. We demonstrated that the system is working. We have evaluated the quality of service of the system and everything fine. But there are still other challenges. So how can I use my system in order to execute artificial intelligence applications? Because now if I have a drone, it's funny, but what I can do with a drone? I'm going to take pictures, and these pictures will contain information. So I need to process these pictures in order to extract the information. For example, in case of disaster management, okay, we can actually survey an area, and we want, for example, to identify injured people or people that need help. But I need sophisticated algorithms that will extract the information and tell me that there is an injured person in this location, okay, or there is an event in the other location. And for this, we need AI. Okay, and AI nowadays, like Andronji said, is the new electricity. Okay, so now, yeah, so it's the new electricity, and now we move to the second part of the benefit of cloud, that is computation offloading. We need to offload computation from the drone or the robot into the cloud, because it's not efficient to run these hungry computations on board on the drone. It's going to complete and finish the battery quite fast. So I'm going to give you a brief overview about artificial intelligence. Anyone has prior knowledge on AI, deep learning? Because I planned here a small introduction. Okay. Okay, so artificial intelligence started like from the 50s. It's the big word, where people start to think about automation, how to automate the process, adding some intelligence into the robots and so on. And then, maybe around the 80s and 2010, people looked into machine learning, which is a branch of AI. And machine learning, there are different algorithms like clustering, classification, and for example, spam detection, and different applications for this. And starting from 2010, we start to hear about deep learning, which is a branch inside machine learning. And it is based on neural network, and it gives powerful functionalities that allows you, for example, to tell what are the different objects inside the picture, which was a very challenging problem until deep learning actually came through. So the advantage of deep learning in initial machine learning techniques, feature extraction was kind of being done manually. Okay, so usually it's a tedious and long process, and then the machine learning technique will just be used for doing the classification and finally tell you what is in the picture. But with deep learning, now current techniques, they allow you to combine both feature extraction. I'm going to show you what is feature extraction later, and also perform classification and even more. So why deep learning becomes very important? Until 2011, there is a competition, annual competition, that is done in computer vision. There is the ImageNet dataset. It's a big dataset. I think it contains millions of images. And people every year, they develop new algorithms. They come and they will see which algorithm performs better. So until 2011, the best or the least error found was 25%. It means the best recognition was only 75%, correct? Okay, with classical algorithms that were before deep learning. Until AlexNet came in 2012, using convolutional neural network, and it made a revolution by making a substantial decrease. So look at the decrease here, it's only 3%. But here it's a very big decrease, it's almost 10%, okay, of improvement. And people start to be very excited about using convolutional neural network. And every year, so we have very good reduction of error until it comes up to 4% or 3.5. So this is actually why deep learning is now attracting a lot of people and is taking place everywhere. By the way, last week I was in Morocco, and it was a communication purely on networking and communication. I'm not wrong if I say that maybe 30% or 35% of the paper are related to machine learning and AI in a pure network and communication conference. And this says, so in security, in communication, cognitive radius, AI is involved everywhere. So it's not only in computer vision or in robotics, but it's now being integrated in several areas. So you can see here, this is the history of the different techniques for computer vision, like the Hawk technique, SIFT, and Cascade, until 2012. So we have deep convolutional neural network, and then we have different other techniques, so faster RCNN, and also YOLO came afterward, and they were like a breakthrough for the AI algorithms. And this is a survey that confirms what I'm saying. So the history begins from AlexNet. If anyone is concerned with starting with deep learning and AI, you need to start from, all the AlexNet is almost outdated now, but this is the starting point, because it gives you all the basics that you need to start. This is like the ABC or the Hello World example of deep learning. Okay, and nowadays there are so many branches and research around deep learning approaches. So you can see this paper. This guy doesn't have too much paper, but I think it has 45,000 citations. I think he can retire early. Yeah. So you can see this paper, how many, it's almost the most highly cited papers in deep learning. because this is the step. Okay, and it's from 2012. And the guy is from Hinton Group. Hinton, like this is the big guy of artificial intelligence. And by the way, from what I heard, Hinton was working on neural networks since a long time ago. And nobody was caring about him. They say, oh, this neural network doesn't work. It's kind of wasting time and so on. Until 2012, everything shifted back to neural network. But neural network was kind of something imaginary that doesn't have real application in practice and so on. Until it was proven the opposite by. But also, the surprising thing that there is no theoretical background behind deep learning. Nobody understands why it works, but it's actually working. So it's kind of try and check. Okay, you try to make calibration, changing parameters and so on, until it works. And if it works, well, you can have a paper. But why it works, nobody knows. Yeah, that's the relative things. So neural networks, the basic idea is actually you can provide inputs, okay, to a network of neurons, and these. So let's say these are pixels of images. They will go through the network, and at the end, with certain probability, it will tell you, for example, this is a dog or not dog, this is a cat or not cat, or so on. It works like this. So you can see about these different circles like weights like W and B, bias and weight. And they are going to be tuned. They are going to be tuned during the learning process, such that when you provide a new input that you didn't provide before, it will tell you with certain probability the correct output. That's the whole idea. Okay. You know this little girl? This is my daughter. I made an experiment on deep learning with her. Okay? So I give my daughter some pictures. Okay, who is this guy? So we'll say, this is my brother, this is my father. So let me show you. Okay. Let me put the sound.
عيسى شوف هاي قلي هذا شكون هذا شكون وهذا شكون
مريم. This is my father.
هذا شكون هذا وهذا شكون هذا شكون
This is her father. She told me this is Papa, this is my father. This is how deep learning works actually. Yes. This problem is called the problem of overfitting. Why? Because her father has a beard. Okay, so she learned that her father has a beard. So anyone who has a beard is her father. And one time she went in a taxi and he has a beard and said, Papa. It was not mine. This is actually how deep learning works. So we're going to provide many images. So my little girl has learned over the time faces, and she was able to label these faces. But of course, when there is for example, some feature, like for example the beard for my case, she's going to generalize this. This also happens with deep learning, and this problem is called the overfitting problem. Okay? For example, if you put a lot of objects like dog, 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 if you put, for example, a wolf, so maybe the machine is going to say, this is a dog. Okay, so in this case, we have to train again. I have to tell my daughter, no, this is not your father. This is someone else. Now she started to differentiate again between the previous input and the new input in order to improve her recognition. So this is similar things on what happens with also machine learning and deep learning algorithms. So let me give you some intuition about machine learning. This is an image. For you, you can observe that this is 3, right? And these are pixels. Let's say there are only white and black pixels. But imagine for a computer how to tell that this image is 3. It's a very difficult problem. For us as human, it's very easy to differentiate this. But for computer, it's really very difficult. So this is what happens. So you can think about your network as something like this. They have different weights. And for every pixel, for every configuration, is going to go through the network. And at the end, there is a final layer that will tell you what's inside this image. Okay? Of course, there are different layers of for a neural network, and one of them is the feature extraction. So look, for example, this is A. Usually what we do, we use a kernel. You can see that there is a moving square, and it's going to extract information from the image. And then it's going to provide kind of first layer. This is a feature. It's not an A, but it's a feature of A. Okay, and it's going to do this through several layers, and every time it makes a reduction of the space. We start from high resolution image, and then we reduce, we reduce, we reduce. It's like we're extracting the meat from the picture. Until the end, we are able to tell what is inside the image. So basically, this is how it works with convolutional neural network. So this process here is called feature extraction, and it's going to repeat it several times. Every time we reduce the dimensionality of the image, until at the end we are able to say, for this particular feature, it corresponds to this particular image. So in computer vision and AI, there are different research areas. So the simplest one is classification. Okay, classification, it means finding a bounding box around the object of interest. So here we have a cat, and we are going to make a bounding box around the cat. There is also semantic segmentation. It's more complicated because you will make the region with different colors, the region for the background, the object, and the different other backgrounds. We have object detection and instance segmentation. So instance segmentation is only going to make colors for the instances. Another interesting area is the GANs, generative adversarial networks. And GANs are really very exciting. So basically, it allows to generate fake data based on real data. Let me give you an example. This one. So using GANs, for example, we can convert a horse to a zebra. Okay? And the idea of GANs, this generator is going to, for example, now we can generate faces of humans. And you cannot differentiate whether this is fake or real. So what happens? The generator is going to generate something, a complete noise in the beginning. Okay? And then it will send to the discriminator. The discriminator, no, oh, this is wrong. This is a noise. So, and then the generator is going to learn from this region. And is going to improve itself. And the next time is going to generate another thing. Until, by learning from the discriminator, is going to improve the generation process until it's able to generate something close to reality, so that even humans cannot differentiate from the reality. This is the idea. So the discriminator has the real samples and is able to differentiate between fake samples and real samples. Imagine that someone makes false money. Okay? So in the beginning, maybe everyone is able to know. But with time, it's going to improve itself until it's able to print money like the real one. Okay? And GAN, it has a lot of usages. So you can look at the internet. You can create new samples and from fake samples from real samples. Okay, so the application of drones with AI, for example, we can use it for photogrammetry. This is the map of the Princeton University campus. I like to play with drones. So here we have collected 300 images, and we have used the Pix4D in order to make a 3D model of the whole campus. And also, it can generate a high-resolution map in 2-dimensional or 3-dimensional space. Here we have used also a drone in order to detect cars at the entrance of the campus. So we can use it, for example, for smart transportation or surveillance. I can show you some other videos here as well. This is using GOLO. So you can see it detects the object with certain confidence. Okay, and of course you can play with the confidence. It can detect this as a track here, as a track. It is used also in smart transportation. Look, there is automatic counting of the number of cars that cross an intersection. And one of our latest work, I'm going to finish with this, is to use the GANs in order for domain translation. So what is the problem here? Imagine that we train a neural network on a city to make semantic segmentation. So then what does it mean? We want to identify the location of houses, the location of the cars, streets, and so on. So we can use, for example, this is from Potsdam city. We can use this one, and we can get an accuracy up to 80%, for example. Now, if you take another city, I think this one is Hagen, or yeah, and you apply the same neural network on this city, you're going to have a degradation, maybe becomes 20% or 30%. Why? Because this domain is completely different from this domain. Okay, look here. There are some red colors. So the interpretation of this picture for the neural network is completely different from this one. Okay, so from 80% of accuracy, we can go down up to 20% of accuracy. So what do you need now? You need to retrain the network on this domain, but we don't have enough. We don't have enough data set for this domain, and also training also has a lot of cost. So what we want to do? We have already the trained network. We want to generate from this domain translated to a domain similar to this one using GANs. So this was the idea of the paper. In order to improve, so you can see even visually, when you look at the images from this domain, it's completely different from the images of this domain. And this actually has a big consequence on the accuracy for the semantic segmentation of the neural network. Okay, so we have proposed a GAN model that allows to learn from the target domain, from the source domain, and make the translation to the target domain, and finally retrain the network. So for example, now, if you provide this to the neural network before making the domain translation, okay, compare this one with the grounded truth. It's completely different. Look at the color here, for example. Here it's blue, and here it's giving something different. So it didn't recognize that this region is the same, okay, of this region. But after making the domain translation and adaptation, we are able to improve the semantic segmentation, because this is vegetation here. But the vegetation here is not green, it's red. So it didn't understand that this is the vegetation, it understands this is something different. But when we're making the adaptation in this case, it improves a lot the accuracy of estimation. Of course, you can see more details into the paper in terms, yeah. So I think I reached 45 minutes. I want to talk about drone safety, but I'm going to stop here. Okay, thank you for your attention, and if you have any questions, please.